Welcome to another lesson of Make Things with C++. Today we are going to be talking about recursion, which is a pretty cool idea in programming. To kind of sum it up simply, just the theory of it, it is basically a function that calls itself. And when it calls itself, it calls itself on a subproblem of the original problem. And that sounds kind of abstract and maybe kind of hard to understand. I find with recursion it's often easier to learn it by an example, which we will do today. I have three different functions that we're going to cover that should give you a great idea of what recursion constitutes. So today we're going to be building a factorial function that gives us the factorial of a number. So in maybe algebra or pre-algebra, you've seen this where we have a number followed by an exclamation mark, and that is to denote that number multiplied by every number below it through 1. So as an example here we have 4, the factorial 4, which is going to be 4 times 3 times 2 times 1, and that comes out to 24. And so recursion is fantastic for problems like this. Again, we take a number and then we split it into subproblems. So we take 4, and then the subproblem would be 3, and then we subproblem that until 2, and then we keep going down until we hit some base case. In this case it would be 1. So that's kind of an overview of how this will work. Our other functions that we will work on today, we're going to return the nth Fibonacci number, and in our next video we will also print an array. We'll take a function that we would normally do iteratively, so we'd go from like 0 to n, printing out an array, and we're going to convert it to a recursive function. So in that next video we will also talk about the pros and cons of using recursion, dipping a little bit more into memory and the costs of running a recursive algorithm, why you would use it versus why you wouldn't. So to get us started, let's go ahead and build out this factorial problem. We are always going to start with the base case. So again, with factorial, the base case is going to be 1. So we would do if n is equal to 1, return n. And the reason we start with the base case is we need to think about where our function is going to stop. If we don't have a base case and we have this factorial calling itself later on, it's going to just keep on calling itself forever, and eventually the program is going to crash because it's going to blow your stack. I don't know if you've heard the term stack overflow, but basically it reserves memory every time it calls itself, and eventually call itself so many times the program would crash. So that is our base case. And then the recursive case, we need to first think about how we are going to make a subproblem of n. So we give it 4, we need it to become 3. Simple enough, we just say n minus 1, and there's our subcase. So if it's not equal to 1, then we want to return n times factorial of n minus 1. And it's that easy. So our function is complete really here. Just to kind of show you how this will work, say we just simply fed it 3 instead of 4. So we give it 3. It comes in here. It's not 1. So instead it will multiply 3 times factorial of 2. So then it'll jump into factorial again. Doesn't yet solve that problem of 3 times factorial 2. It first needs to solve factorial 2. So it jumps back up here with the number 2. Comes in. It's not 1 yet, so it says return 2 times factorial of n minus 1, so that it's factorial of 1. So finally it comes back out with a 1, and it returns that 1, comes back out 1 times 2, returns that, comes back out again to 2 times 3, and there we have it. So that's 6 for factorial of 3. So that's kind of the overview of how recursive functions work. Let's go ahead and test this just so you can see that it actually works. So in our test here, we've created two variables. We have fact, which is going to be the number that we're trying to find a factorial of. So we'll just simply ask the user for a number, and then we'll run our program, and save it to result, and then we're just going to say it out to the user. So let's go ahead and save, compile, and run. So save, compile, and run. And so it pops up here. It's asking us to enter a number. Let's go ahead and just put in 4 since we've already calculated that. And then it pops out. It says the factorial of 4 is 24. Perfect. So it worked. Not bad. So let's take a look at another problem. This one is going to be the Fibonacci sequence. We're going to find the nth number of the Fibonacci sequence. And just kind of an overview, a reminder in case you haven't seen this before, or if you have and you just need a refresher. The Fibonacci sequence is basically taking each of these numbers and adding the last one to it. So for example, this Fibonacci number is the sum of the last 2 behind it. So 1 is equal to 1 plus 0, 2 is equal to 1 plus 1, 3 is equal to 2 plus 1, 5, 3 plus 2, and on and on. So this sequence, it's called the Fibonacci sequence, and as you can see, it's just easily calculated. So for the nth number, so whatever number it is in the sequence, it's always going to be equal to the number right behind it, so n minus 1 plus the number that is 2 positions behind it, so n minus 2. So as you can see here, 21, so that's n, is going to be equal to n minus 2, which is 8, plus n minus 1, which is 13. So as always, we need to start with our base case, and with the Fibonacci sequence, that base case is going to be 0 or 1. So we'll say if n is less than or equal to 1, return n. So if n is 0 or 1, it's going to return that number. Otherwise, we're going to call this algorithm here. We're basically going to call this subproblem. So we'll say else, and we'll just say return, and we're going to call this again. So we'll say Fibonacci n minus 1 plus Fibonacci n minus 2. We're finished already, and it looks super clean, and we're solving something pretty complicated. Again, all we need to do is just feed it the original number. So say we give it 3, it would come in here, doesn't pass the base case, so it would come down here to the else statement, and it would run Fibonacci on n minus 1, so it would run it on 2. So fib of 2, come back up again, come in here, it doesn't achieve 1 again, comes to Fibonacci for 1, back in, returns that 1, and it recurses all the way up until it gives us our answer for the third Fibonacci number. So let's go ahead and test our function here. Let's see what the 8th Fibonacci number is. It should be 21. Let me just count it up. 0, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So we're just going to feed it the number 8, and it should give us the 8th number, which is 21. So again, our test, it looks like this. We're going to have 2 variables. We're going to have the Fibonacci number, or the nth number. So this is going to be what the user gives us, and we have the result. So we'll just ask the user for that number what the nth number of the sequence is. We'll calculate it with our Fibonacci function, and then we'll return it to the user. So let's go ahead and save and run. Alright, so we're going to test it with the number 8. It should come out as 21. And that is exactly what we got. So it is working. And just an overview again really quickly of how this recursive function works. We have the base case as always, that's where we stop. And then if it's not achieving the if clause of the base case, then it is making a subproblem of that original problem and calling itself. And that is called recursion. Good job if you made it this far. In our next video, we're going to talk about the costs of recursion, when you would use it, when you would not use it, and we will also print out an array, something that we would normally do with a for loop. We're going to do it with recursion this time. For deeper learning on C++, visit us at makethingswithcpp.com and be sure to like and subscribe.